Alright, I've been making observations over this bay for a year. This is called the Choctawhatchee Bay. I've been making my observations from Fort Walton Beach side of the bay here. This is Destin here. Miramar Beach over here. This is the Mid-Bay Bridge. This is a toll bridge that runs across the bay. Now this bay does not have tides. Well, it has very small tidal range. The maximum tidal range ever recorded in this bay is 1.5 feet. I think the average tidal difference is 6 inches or so. But I am going to show you these objects I've been observing and proof that the Globers claim that we can see these objects in the distance because of refraction. It's lifting the objects up and causing us to be able to see them. Well, what would cause the refraction is temperature differences between the air and the water. Okay. I'm going to show you beyond any shadow of a doubt that the only thing those temperature differences do is block the objects in the distance. They do not raise them up. The only time you can see these objects is when the air and water temperature are the same. You can have as little as a 10-degree difference in the air and water temperature, and a lot of stuff will be blocked out and you can't see it. And that is the case most of the time. I mean, check your area. You know, here in Florida, it's normally just super hot. You know, we have very mild winters. So in the wintertime, on certain days when the air and water temperature are the same, you can see so much. Now I've got time lapses, I've got all kinds of evidence here for this video. But I'm going to start out showing you my location here that I've been filming from. I've been on this beach for a year. I mean, not every day, of course, but a few times a month I'll go out here and try to get the different weather conditions and temperatures. And I'll pull up in this parking lot. It's a little public park. As you can see, if I'm hovering my cursor over here and look at the elevation down here, it says it's 10 feet above sea level. We go out here 0 feet. I don't know if this is accurate, but I did some measurements anyway. Well, I will show you my measure tool here. Click on my location, and I will show you some of these objects. Okay, you'll see in my videos, I always try to I always look at this gazebo here, and along this little shore. It's only half a mile away, just to show you that that is my location. I've got screenshots of my dioptra, shows location, so I am where I say I am. Here is a house that I show quite often in some of these videos. It is 6.7 miles away. These seawalls here are very low. I've got some pictures of the docks near my side. Since there's no tides, they build these docks very close to the water. You can see it says 8 feet elevation here, so we'll go with that. I've yet to take my boat. I'm going to do that next. I'm going to take my boat over here and just pull up to this wall and measure it. You see exactly where it is. But I also will show this bridge here in some of my videos. This is 10.5 miles away, 10.6, and it goes up to, I can't see quite this far from my location. Here's the channel that goes up under the bridge. Now this bridge is 17 feet off the water all the way across, except for where it goes up over this channel. It is 70 feet to the peak. I have measured this with my I do surveying at work sometimes. I have survey equipment. I have gone out here on this bridge and surveyed it, and it's 70 feet. It's actually 69 feet. That's what my equipment said it was at the very peak, and it's 17 feet where the tires are on the road all the way across it, except for this, like I said, this little section right here. And then I also film this water tower right here, which is 17.5 miles away exactly. Okay, let's click off that. I'll show you the street view of this water tower. You get see your eye altitude down here. The closest I can get to it before it goes to street view is about 140. Oh, I got 134. Wow, I've never got that close before. Not sure exactly how tall this water tower is, but we'll say it's 150 feet. Okay, and I have clear pictures of this from the other side of the bay. Notice it's tan on the bottom, and then it's like a bluish green on the top. Exit the street view. Alright, this is the Earth Curve calculator. You can see I put my eye height. This is my camera height. I put 5 feet, and the water tower 17.5 miles away. And it says 145 feet should be hidden from your view. So you shouldn't see that water tower. Maybe the very tip of it every once in a while. But I will show you that I can see the entire thing. Well, of course not the very bottom because it's blocked by trees and stuff, and then that bridge in front of it. But when the air and water temperature are the same, you can see just about the whole thing. Okay, I said the bridge was 10.5 miles away. And see that bridge says target hidden 40 feet. Now at best the bridge is 20 feet from the water. I said I measured it with my professional equipment. It said 17 feet. We'll call it 20, but so that bridge should be 20 feet. The top of the bridge should be 20 feet below the curvature. But I will also show you cars driving all the way across the bridge when the air and water temperature are the same. And it doesn't matter if the air is colder than the water or warmer than the water, you get the same effect in summer and winter. You get the same thing, you get the blockage, you can't see it. Alright, this is my folder of all the pictures and videos I've taken over this bay over the last year. You see this first one is January 16th, 2018. My last one was just the other day on the 17th, January 2019. Okay, we go into this folder, and I always try to take a picture of my camera right on the beach. It shows my location here, which I can also show you on the map. Pass it. Let's skew my map here. Okay, look at down at the bottom of the screen, the 30 degrees, 25, 48, and then the 86, 36, and 1. Pretty close. I don't know if they're using the same thing or not, if it's really accurate. Phone could be a little off, the map could be a little off, but that is my location. Here is a shot of some docks that I will show. That some days you cannot see these at all. Now, these are 6.5 miles away, something like that. Here's a video I took. Okay, in some parts of this here, you can actually watch the cars driving by on the bridge. That's me zooming out, show those right there on the beach. There was my water tower over there. Look, see that car driving by? See those cars? That's that bridge that's 10.5 miles away. That's supposed to be, the top of it's supposed to be 20 feet below the horizon. But you can clearly see the cars driving by in the background. Now, you still got high humidity. You're still looking through some, dense air, but you're not getting the refraction or the the mirroring, the inferior, superior mirages, whatever you want to call it. But you can see this line right between the bridge and the water. It's looking underneath the bridge. I've got pictures I've taken standing right down there at it. But I'll show you the temperature for this day. It was, let's say it was about 1 p.m. That was January the 16th, 2018. We'll go down to the temperatures at about 1 p.m., 12:53 here, 62 degrees. It was 56% humidity right then. And the water temperature for average January sea temperature is between 60 and 63. So that's right in the same range. So I will definitely show you that when these temperatures are different, that's when you get the blockage. And here's the gazebo that's a half a mile in front of me. That shoreline over there is about 6.5 miles away. A bit of bad camera work here. Sorry about that. But you can see these. See, you can see the seawalls. You shouldn't be able to see that. You should not be able to see. Look, you can see the beach over here. And it's at 6.5 miles away. Like I said, the temperatures were the same. You still got to deal with humidity and haziness and all that, but you don't get all the mirroring. Like nothing's being loomed up. This is a very low refraction day. You still can't see forever, of course, because of the humidity and the atmosphere, but you can see stuff that should not be seen. According to your ball model, water does not curve. I'm going to try to get through some of this kind of quick. I don't want this video to take forever, but this is a year's worth of work, and I've got quite a bit to show you. All right, now we're going to look at March 16th of 2018, and you can see This picture here, took at 9:14 a.m. Now look at this tree here, and that's that piece of that dock. That's the one from January, March. January, March. Same beach, same camera height, same tripod, same everything. What has changed? The temperature. Okay, in March, on March 16th, 2018 at 9:14 a.m. There we go. March 16th, 2018 at, let's say, around 9 a.m. The temperature was 54 degrees, and the sea temperature for March is between 62 to 67. That's about a 10-degree difference, and you see the extreme difference in what you can see. Simple, easy, provable. Anyone can go out and do this. Anybody. Just look at the air and water temperatures. Alright, next we're going to look at April the 18th. There's your water tower. It's at 9:35 a.m. April 18th at 8:53 a.m. 9:53, 74 to 76 degrees. Your sea temperatures average 67 to 73, so they're probably pretty close to the same there. You can see most of the water tower. Some of it's blocked down here. Might be the top of the bridge right there. Let's see if I got a video here. April. So see, I always try to show my camera leg right there with the water splashing up on it. Sometimes it makes my camera leg sink, messes my shots up a little bit, especially if I'm doing a time lapse. There's my gazebo there on the right. See the docks over here. See the water tower. Boat out there on the horizon. Very little, almost no mirroring going on out here today because the temperatures are the same, are very close to the same. But, this water level can look different all the time, but it's not changing. It's just the optics, it's the atmosphere, it's the humidity, it's the temperature differences. When the temperature is the same, you can see much more. So that's 17.5 miles away. You shouldn't even be able to see that much of it. There's my docks again. Some days you can't see these at all. And I'll show you, winter and summer where these things are blocked by the mirroring. Alright, let's go to April the 20th at 10:17 a.m. I took this picture. We go to April the 20th at about 9:53 is the closest they got. 64 degrees. I said the average water temperature was 67 to 73. So, that's, the air's cooler than the water. You get blockage. see if I got some videos on that day. Start out showing my front leg of my camera in the water. Zooming out, you can't even see the water tower. See, no water tower. There's the channel marker mirror. Look at all the mirroring. You can't see the docks. Can't see anything. These trees are mirrored down on themselves. You know, these are the effects you get with just a few degrees in temperature difference. I mean, you know, look at this boat. Look at it mirroring down. You know, you can't tell where the horizon is. I mean, the horizon's probably up here. See the waves come off this boat in the mirror line. You know, you call this superior mirage, whatever you want to call it. But it's not curvature. You can't even see none of the houses over there on this day. Air is cooler than the water. Nothing's being brought up over the horizon because the temperature difference is being hidden. I also took this video on the same day, April the 20th. I followed this boat until I couldn't see it anymore. You can watch it enter the mirror line, the mirage line. You know, fast forward through it a little bit, but you can see it mirroring. It's not going over a curve, people. Water does not curve. This is all optical. Look at that. Look how it stretches as it gets further away. And you'll see looks like the bottom's starting to disappear. Now, you can't see this. I think at this point, you probably couldn't even see this boat with your eyes anymore. You would think it did disappear bottom first, but over a curve, but it's obviously not. And it's so obvious. You know, I followed this boat till it vanished. It vanishes into the horizon. It never dips down over any curve. See there? There it goes. It's still going. And then finally, it disappears altogether. But and this is from temperature differences. Alright, now we're going to look at May 3rd, 2018. There's my camera on my tripod as normal. Same spot. Look at May 30th, 2018. Oh, what time was that? That was at 1:45 p.m. So let's go to 1:45 p.m. Now 1:53 is close. Says it was 82 degrees out with 82% humidity. You look at the average sea temperature for May, 73 to 79. So the air was warmer than the water on this day. And you still get mirroring. This house mirrored down on itself. Let's see what I got for video on this day. I always like to show them. I'm right at the edge of the water. Let's see what I got here. There's my gazebo, half-mile in front of me. And there is your mirroring. Very, very similar to what you get when the temperature is the other way. Today the air is warmer than the water. It's the same effects as when the air is cooler. than the water. You still get the same effects. Same miraging, same mirroring. That is what is blocking your view. See, no, you can't see the docks over here at all. It's probably it's probably another day where you can't see the water tower. There's a sailboat off in the distance. It's just that sail is mirrored down. You're just seeing a mirror reflection of the sail. The sailboat's not behind a curve. Just pan around. See, no water tower on this day. Alright, let's look at September the 18th at about 2:43 p.m. And September 18th, 2:41 p.m., pretty close, 91 degrees. Average sea temperature in September is 81 to 84, so you get about a 10-degree difference there once again. And it's the opposite way. The air is warmer than the water, so you get the same type of mirroring. And blockage, and you see how low these docks are, because there's no tides here. Like I said, there's 1.5 feet is the most tide you get out here. So all these docks and seawalls are very low. There's my gazebo, and there is mirroring, blocking your view. And autofocus is not the greatest. See, there's a boat out there in the mirror line. Come on. Let's look at the next one I got. See all the mirroring? You can't see the docks over there. There's my house. I'm always filming. Look at that. How it's mirrored down on itself. Same effects. Doesn't matter which way the temperature swings. Doesn't matter if the air is warmer than the water or colder than the water. You get the exact same effects. This is repeatable, testable, provable. Anyone can do this. You know, I'm tired of the Globers saying that the refractions is what's making you see things. It's not. It's blocking things. This is absolute proof. You can't deny it. I mean, well, you can deny it, but this is proof. Go out, do this yourself. This is what has been called curvature forever. I mean, don't you think they were smart enough to figure this out a long time ago? I mean, probably more than 90% of the time, this is what you're going to see. It's very rare, especially here, that you're going to get the air and water temperature the same. It might only happen a few times a year for an hour a day, you know. But this is just how it is. This is reality. This is the real world observations. You know, we're not talking about the Globers where they're cheating and they're lying and deception, trying to shoot lasers across ice and water to show that you can bend a laser with these extreme temperatures. I mean, nobody's saying that temperature differences don't make a difference in what you see, but it does not allow you to see more than what's there. Period. Alright, now we're going to skip ahead to December the 5th of 2018. This is at 12:35 p.m. See, I have my camera down here at the waterline. Your average sea temperature is 65 to 68, and the air temperature was about 54, 53, 54. So once again, cold air over warmer water. And on this day, I had my camera on the beach again. And I looked out and I could not see the water tower, but when I drove up in the parking lot, which I'll show you in a minute, so it's a little bit higher, it's probably 10 feet above sea level in the parking lot. Thought I could barely see the water tower when I pulled up. Look at all this terrible mirroring. Horrible mirroring going on. It's got everything blocked. You know, can't see these docks, you can't see the houses. You know, you can't see anything over here because of the temperature difference and the mirroring. Show me an example in reality where a temperature difference is going to loom something up. It doesn't happen. It's blocking things. That's plain and simple. This is provable. I know I keep saying it over and over, but and this is the norm. This is normally what you will see. Like I said, it's very rare, especially here, for the temperature to be the same. Okay. So I went up higher. This is up on this railing, which is just above sea level a little bit. And this is what I saw. Look at this. The water tower looks like it's floating way above the surface of the water. What do you think? What do you think that is? That's the temperature difference. See if I got the video of that. So yeah, this is from up top. Look at that. Water tower looks like it's floating above the water. As autofocus goes crazy when you're out here. But from this height, you can see the tops of the houses now. But this is all caused by the temperature differences. Alright, here's another shot of this house that I'm always observing. This is on December 13th at 9:56 a.m. And look, just a few days later, how long was this taking? Crap. This is on the 26th at 12:26 p.m. You can see the seawall or whatever, maybe part of the yard here, and here it looks like the water's above it. Guess what, folks? Once again, look how the bottom floor looks stretched in that one, more compressed in that one. I mean, this is all due to the atmospheric effects, nothing else. There is no curvature. Alright, this is January 8th, 2019. Look how good you can see the water tower this day. Remember I showed you the tan with the aqua top? That is the water tower. 17.5 miles away. This was January 8th, 2:44 p.m. Let's go to January 8th, 2019. Time I say 2:44 p.m. I'm gonna hit you. to see 68 degrees. Average sea temperature in January. Is 60 to 65. But we actually had some very good views on this day. As you can see, the water tower there. One, two. Go through this again. This is pretty important stuff here. This is what the Globers always get backwards, completely backwards. Look how good you can see the stuff over there on this day. Look at the houses. 6.5 miles away. Look at that. You can see the ground over there. Some days you can't see the house at all. The days you can't see the house at all is the days that the Globers go out. That's the times they do their observations. I know some of them are smart enough to figure this out, and they just pick and choose their times. They don't, you know, when they capture this stuff, they're not going to show it. If they do capture it, I don't know. Maybe they hadn't figured it out. And there, once again, the water tower. This is one of the best days I ever saw it. And once again, you can see the little, look real close, you can see the cars driving across the bridge back there, but see, there's the hump in the bridge for the channel. It comes down. Watch the car going across. Just another example of the different view you'll get. So you can clearly see the colors, and then it's mirrored down onto itself here. This is because of the difference in the temperature. Once again, I got example after example after example. I'm going to go ahead and show you me measuring my camera lens on the tripod. This is the P1000. It's about 4.5 feet. Right there on the edge of the water. Same place I always. It was actually 4 feet 5 1/4 inches to the center of the lens. So that's why I put 5 feet in the curve calculator to give it every chance. And then here is the height of the. I was making the observations from the parking lot. See, this is 3 feet, almost 9 inches. When I had my camera up behind the railing up there. But it doesn't matter what height you put in, you should not be able to see any of this. So there's another time when the water tower looked like it's floating above the water. And I'm going to show you some time lapses I did. Try to end this up here. Let's see, this is a good one. Yeah, I was able to actually predict exactly. I see my camera fell down in the water on that one. Actually able to predict when this shift would happen because I looked at my water temperature and the air temperature, and I got out there an hour before the shift was about to happen and took these time lapses and this is the one where you can see it start to clear up. That's when the temperatures start to match right there. Also did it with the water tower. Okay, this is the superlapse with the P1000 on the water tower. I was catching the shift in temperature. And started out with the air colder than the water, and as the air temperature rose, it started to match the water temperature. You can start to see more and more of this water tower. See how the mirroring on itself is getting lower and lower. Slowly watch the mirror line go away. So this was the P1000 superlapse mode. This was about an hour's worth. I was out there for about an hour this day. Let's see. There you go. See that you start seeing more and more and more of it. And then you can start to see the bridge come into view. Real world observations, people. There's the bridge. Look at that. You can see clear under the bridge. Real world observations, not, trying to deceive like the Glovers. This can all be explained by the atmosphere, temperature differences. You can't see forever, but you're going to get the best views, like I said, when the air and water temperature are the same. Humidity does play a big role in it too. Isn't that awesome? And then I will go ahead. This is where I put the time lapses together of this house. Let's see a little bit better. Now watch over on the left. See the dock start to appear, seemingly out of nowhere. I should have got to the left a little bit more, but and then you can see the house in all its glory. I'm going to finish up with this. This is a Glober that is trying to prove that things are being brought back from around a curve because of the atmosphere. Now he takes this, just watch. He takes this propane tank and then he's got this back here behind it, which is not really on the curve of the tank, but way behind the tank. He's got to put his camera on the ground. Set it up and look up at it, and he pours liquid butane on the top of this tank to try to prove that we're all wrong. But this in no way represents reality, as I just showed you for the last 40 minutes of my observations of the real world. Oh, look there. Now the red, what happens? The red comes up and blocks the green. I guarantee if you raise this camera up to the same level as that propane tank, you'd probably see the red. The Glovers are smart enough to figure out how to deceive like this. I mean, I just don't understand it. And they say we're the ones that are crazy. But anyway, that's all I got for this one. I know this was a kind of long one. Hope y'all liked it. Alright, that's it for this one. Let me know what y'all think about this in the comments. I think this is pretty indisputable. And if any of these Glovers were honest with themselves, they would see this. I think these nameless, faceless ones like the Wolfies and the Soundlies and all that, they know it's flat. They they hide their identity because when all this comes out, all they have to do is shut down their channel, and nobody will ever know who it was. You know, they don't want to endure the ridicule. I mean, this is coming out. There's no doubt about it. It's flat, folks. I said, go out, test things for yourself. This is all pretty simple, easy to figure out. All right, see y'all on the next one.